There are few enzymes whose names have been established by long usage, such as ptyalin, pepsin, trypsin, and eripsin. Apart from these, enzymes are usually named by adding the suffixes to the main part of the name of the substrate upon which they act. Thus, amylases acts upon starch, lactase acts upon lactose, lipases acts upon lipids, maltase acts upon maltose, and proteases act upon lipids. Maltase acts upon maltose and proteases act upon proteins. However, several enzymes which act upon many substances in different ways. These enzymes are named by their function rather than substrates. Thus, an enzyme which causes deanimations is called a deaminase, and oxidizing enzyme an oxidase. Some enzymes work efficiently only if some other specific substance is present in addition to substrate. This other substance is known as an activator or a coenzyme. Activators are usually inorganic ions. They increase the activity of a complete enzyme and may take part in formation of the enzyme substrate complex. Many of the coenzymes are related to vitamins. This explains why vitamin deficiency profoundly alters metabolism. Thus, for instance, thiamine as thiamine pyrophosphate functions as a coenzyme in at least 14 enzyme systems. Coenzymes like enzymes are being continuously regenerated in the cells. Enzymes play a decisive role in the digestion of the food, as they are responsible for the chemical changes which the food undergoes during digestion. The chemical changes comprise the breaking up of the large molecules of the carbohydrates, fats, and proteins into smaller ones, or the conversion of complex substances into simple ones, which can be absorbed by the intestines. They also control the numerous reactions by which these simple substances are utilized in the body for building up new tissues and producing energy. The enzymes themselves are not broken down or changed in the process. They remain as powerful at the end of a reaction as they were at the beginning. Moreover, very small amounts can convert large amounts of the material. They are thus true catalysts. The process of digestion begins in the mouth. The saliva in the mouth, besides helping to masticate the food, carries an enzyme called ptyalin, which begins the chemical action of digestion. It initiates the catabolism, breakdown of the carbohydrates by converting starches into simple sugars. This explains the need for thorough mastication of starchy food in the mouth. If this is not done, the ptyalin cannot carry out its functions, as it is active in an alkaline, neutral, or slightly acid medium and is inactivated by highly acid gastric juices in the stomach. Although enzymatic action starts while food is being chewed, digestion moves into high gear only when the chewed food has passed the esophagus and reached the stomach. While the physical action is peristalsis churns and kneads solid food into a semi-solid amorphous mixture called chyme. This mixture undergoes chemical change initiated by gastric juices secreted by the walls of the stomach. These juices include mucus for lubricating the stomach, hydrochloric acid, and gastric juice. The enzyme or the activated principle of the gastric juice is pepsin. The enzyme in combination with the hydrochloric acid starts the breakdown of the proteins into absorbable amino acids called polypeptides. An additional enzyme renin plays an important role in the stomach of the infant. It curdles milk and allows the pepsin to work upon it. The gastric juice has no effect upon starches or fats. When the chyme leaves the stomach and enters the small intestine through the pylorus, the lower escape valve, it still contains much food which is in the form of raw material, not yet ready for absorption in the body. Digestion is completed inside the small intestine by several juices. From liver comes a liquid called bile which converts fat globules into a smooth emulsion. The pancreas contributes various enzymes which continue the breakdown of proteins, helps to divide starch into sugars and work with bile in digesting fats. The small intestine itself secretes enzymes from its inner wall to complete the reaction. When all the enzymes have done their work, the food is digested and rendered fit for absorption by the system.